Let's look at one more example in lesson 52. This one actually uses two constituents because we have salt and water. If you have two constituents, you can actually solve two different ways. Salt or the water way. You can use one or the other, whatever the constituents are. Let me show you how it got to here though. So the chemist has one solution, 10% salt and 90% water. So this is referring to our first solution. It is 10% salt. So therefore we could say 0.1 salt 1. Salt 1 and it's 10%. If it's 0.1 salt 1, it just says this one in the problem. It tells you 90% water. So we can say 90%, 0.9, water 1. So that's the first solution. Second solution says another solution that is 2% salt. So salt 2, 2%, 0.02, salt 2. Or if we were doing water, that would be the difference of 0.02 or 2% and 100%. So that would be 98%, 0.98 water 2, since it's our second solution. Then it says, how many milliliters of each should the chemist use to make the total of 1,400 milliliters? So this is the total salt, total water. How many of each should they use to make that total? So that would be considered our salt 3 or water 3. Oh, and it says 6% salt. So we would plug in 6% times the total, 1,400, and then 94% times the total, 1,400. For both, once again, you bring down, so this is the percent row, this is the measurement row, so milliliters in this problem. So water 1 plus water 2 equals your total amount of milliliters, or water 3, 1,400. Same one for salt. Let's go ahead and solve this water one. Either way should come out and work the same. So water, let's subtract the water 2 to get water 1 equals 1,400 minus W2. And then we can plug in 1,400 minus W2 for W1, since we know the value of it now. 0.9 1,400 minus water 2 plus 0.98 water 2 equals, that would be 1,400 times 0.94 is 1316. And now we continue to solve. 0.9 times 1,400, 1260, minus 0.9 W2 plus 0.98 W2 equals 1316. Subtract 1260 to get oops, put that wrong. 1316 minus 1260, 56 equals negative 0.9 plus 0.98 is 0.08 water 2. Divide to get 700 milliliters. 700 milliliters is, what was that? W2. Well, if that's 700, and your total is W1 plus W2 equals 1,400, that means W1 is also 700. And remember, we write our answer like so. 700 milliliters it was at 90%, and 700 milliliters at 98% was the solution. And that's how you do chemical type A problems. In lesson 52, we're going to learn about chemical type A word problems. Chemical type A word problems. Now, what a type A problem is where you have two different constituents. And what that simply means, think of a, not chemical necessarily, but something like water, antifreeze, we're about to use iodine, salt, things like that. In type A problems, two of those are mixed. Often one constituent is mixed with another. It may be mixed with a different one. For example, water may be mixed with salt. And we'll actually do that in the second example. But let me show you what all this means now. In example 1, we're actually mixing two of the same constituents because everything is iodine. Okay. So it reads, a druggist has one solution that is 10% iodine, another 50% iodine. How much of each should they use to get 100 milliliters of a mixture that is 20% iodine? Now I wrote down kind of the solution to do everything, but I want to describe it. But, hopefully this helps you see it. Let's look at this in a picture format. Maybe this helps some of you visual learners. A druggist has one solution that is 10% iodine. Okay? One solution that's 10% iodine. So imagine this is a cup or whatever, and it has a solution that is 10% iodine. I'm going to refer to that as iodine 1. There's a little 1 right here. Then they have another solution that is 50% iodine. I know the water levels are equal in these, but this solution has 50% iodine. So I'd put in iodine 2. It says how much of each should they use to get 100 milliliters? Okay, how much of each should they use to get 100 milliliters of 20% iodine? So how much of 10% iodine 1 and 50% iodine 2 do they need to dump in here to get 20% of iodine that is at 100 milliliters? I'm going to refer to this one as iodine 3 because it's our third solution. And iodine 3 can be referred to as the total. So now, how do we solve that mathematically? Well, how I can write this is 10% of iodine 1, because that's one solution, 10% of, meaning multiply, iodine 1, plus, because it has another that will be mixed, plus 50% iodine 2, equals, since we're combining those two to equal this last one, equals a mixture that is 20% iodine 3. Now here's the thing. We actually know that iodine 3, we actually know that is 100 milliliters. We know the measurement. So rather than writing iodine 3, this is what it would technically look like if we're going by what we're doing. Rather than writing that, we can actually write 100, since we know that it's 100 milliliters. So this is what I consider our percentage row. This has our percentage of the amount of each iodine that we are using. The next row is my measurement. This is now our measurement here is milliliters. So this is my measurement row. And so this one, we ignore the percents. We don't use those. So we say iodine 1, we drag this down, plus iodine 2, once again, would equal iodine 3. And that's very basic, as it should be. Once again, we know iodine 3 is 100. So we're just substituting 100 in for our total. So now we have an equation that looks like this, and I put it in brackets. Well, if you remember in Algebra 2, it oftentimes is going to come back to substitution and elimination. So what we could do from this point is subtract iodine 2 from both sides. So now we have iodine 1 equals 100 minus iodine 2. All right. Iodine 1 equals 100 minus iodine 2. Now we can substitute that in for iodine 1. I'm going to make this look nice again. But we're going to substitute here for iodine 1. So 0.1 times 100 minus iodine 2. Just brought that over here since iodine 1 equals that. Plus 0.5 iodine 2 equals 0.2 times 100. I'm going to go ahead and solve that in my calculator. 20% of 100 is 20. Duh. So now we're at this point. We only have iodine 2, so we can solve. We distribute 0.1 times 100 is 10, minus 0.1 iodine 2, plus 0.5 iodine 2 equals 20. Subtract my 10, and that's 10 here. Add my iodine 2's, negative 0.1 plus 0.5 is 0.4 iodine 2. Divide. And 10 divided by 0.4 is 25. So I'm going to write over here, iodine 2 equals 25 milliliters. Iodine 2 equals 25 milliliters. Therefore, if this is 25, we know that iodine 1 is 75. You could plug it in anywhere. But iodine 1 equals 75 milliliters. So now that we've solved for iodine 1 and iodine 2, here is how you write the answer. We write, okay, iodine 1, 75 milliliters at its percentage was 10%, and 25 milliliters at 50%. This would be our answer. We simply now know the value of iodine 1 and said 75 milliliters at its percentage was 10, and 25 milliliters, because we knew I2, at 50%. And then that would be how you would write the answer. Let's go to the next problem.